Okay, so this question is a very standard question on the chapter probability. Okay, so let us try to understand this question. There are three different coins. Okay, and one is a two-headed coin, which means it has heads on both the faces, and another is a biased coin which gives heads 75% of the times, and third is also a biased coin which gives tails 40% of the times. Now the question is, one of the three coins is chosen at random. One of the three coins is chosen at random and tossed, and it shows heads. What is the probability that it was the two-headed coin? Okay, so basically there are three types of coin with us: type A, type B, and type C. Okay, what I do, I select one of the coins. Okay, I am left with one coin. Now I don't know which coin this is. It can be A, B, or C. After that, what I do, I toss the coin and I get my outcome. This is the basic flow of the experiment, right? Now, according to the question, what is happening? It is already given to us that the outcome is what? Outcome is heads, right? So the last process is actually given to us. Outcome is given to us. And now what is the question? That which coin was tossed? Which coin is tossed so that I am getting heads? So this particular process in which the last process is given to you and the probability of previous process is asked, it becomes your inverse probability question, right? Okay, now inverse probability or Bayes theorem is nothing but combination of conditional probability and total probability theorem, right? So before we further proceed, let us first try to write this data 75%, 40% in terms of notations. Okay, so if I say that you are given the A type of coin, then what is the probability of head? Since I am saying that I have given you A type of coin, so I should write a conditional probability statement that you will be finding heads, probability heads. If the coin given to you is A, then in that case probability becomes 1 because both sides are what? Heads. In a similar way, I can write one more expression, probability of getting heads, when the coin that I have selected or the coin that I have given to you is what? Of type B. Then in that case the probability becomes 3 by 4. And similarly in case C, when I try to find probability of heads given that the coin is C, then it becomes how much? 60 upon 3, which is 3 by 5. Okay, so these are the three values with us. Okay, now again if you look at the question, then the question is, what is the probability that it was two-headed coin given that the outcome which we see is heads, which means that I should write this statement: what is the probability of the coin that was selected was of A type given that the outcome that I have is heads. So now this statement is actually a conditional probability, right, which can be expanded using the basic definition of conditional probability, which will give us probability of A intersection H upon probability of H. Right, now probability of A intersection H can be further written as probability of A into probability of H given A. This is again obtained using the definition of conditional probability when we apply conditional probability only to A and H, right? Now the good thing about this numerator is both the values are known to us. Probability of A, what is the probability of selecting the first coin? Since we are selecting the coins at random, now they have equal probability of selection, so PA, PB and PC, if these are the probability of selecting the three coins, then each has the probability 1 by 3, right? So this value is known to us, and probability of heads given that I am selecting the A type of coin is also known. It is equal to 1, right? But now we come to the denominator. we have to find probability of heads, right? But we cannot directly find the head because it is what? It is the outcome. Before I get the outcome, I have to first select a coin and only then I can toss, right? So everything is happening in step by step process. So head can occur in three different process. Either I can select the A coin and then I will get head, or I will select the B coin and then I will get head, or I will select the C coin and then I will get head, right? Okay, so how to write this? So it can be written in terms of notation as probability of A, I am getting coin A, and once I have A, what is the probability of heads? That's how I will get head. Or I will select B type of coin, and then since I have B type of coin, what is the probability of heads? Or I have C type of coin, and then what is the probability of heads if I have C type of coin? All these on addition will give me probability of getting a head. This is actually a statement of total probability theorem, correct? This becomes our denominator, but this on solution gives us what value? PA is 1 by 3, so 1 by 3 into H given A is 1 plus PB is also 1 by 3, but probability of H given B is 3 by 4, that we have already seen, and probability of C, that is again 1 by 3, and probability of H given C is 3 by 5, that we have seen, right? So this on simplification will give us our value, which is 47 by 60. So this becomes our denominator, 47 upon 60. But what is our numerator? Numerator is this particular first thing, PA into probability of H given A, which is 1 by 3. So let us write that also. So it will be 1 by 3 upon 47 upon 60, which is becoming equal to 20 upon 47. This is your final answer.